the direction of a vector with respect to its components x, y, z. So we are going to see how we determine the direction of a vector with respect to the three axes, okay? X, y, z. This is to mean the direction of a vector in space. In space. Now, since the vector is in space in 3D, it's making angle with each axis. Look, here in green, now the vector v in red is making an angle theta with the x-axis and an angle alpha with the y-axis and an angle gamma with the z-axis. Now all these axes are making angle with the vector so that they are adjacent. In our trigonometry, in our trigonometry calculation, now the adjacents are treated in the cosine, okay, using the cosine. For instance, cos theta is equal to a along x divided by, or v along x divided by the magnitude of v. So that this implies theta is equal to cos inverse v along x divided by v. This is the direction of the vector with respect to x, with respect to the x-axis. In the same manner, cos alpha is equal to, okay, here, now, okay, again, invisibly here, okay, now cos alpha is equal to, this is a v y, this is v x, okay, and this is vz, okay, vz. So that cos alpha is equal to vy divided by the magnitude of v, implying that alpha is equal to cos inverse vy divided by v. And gamma, the angle between z and the vector, can be again determined as cos gamma is equal to vz divided by v. Again, this implies gamma is equal to cos inverse vz divided by v. Now these angles are said to be the directions with respect to the axes, with respect to x, y, and z. Now it's possible to find the value of the exact value, the degree measure of alpha, theta, and gamma. So this is how we determine, these are the direction cosines, okay, and this is the direction with respect to x, this is the direction of the vector with respect to y, and this is the direction of the vector with respect to z. Now, just to summarize, now the vector is making, since it's in space, it's making angle with the x, the y, and the z-axis, so that now the angle it make with the x-axis can be calculated as theta, which is cos inverse vx over v, and the angle it make with the y-axis can be calculated as alpha, which is cos inverse vy over magnitude of v, and the angle it make with the z-axis can be calculated as gamma, which is a ratio, or which is cos inverse of vz over v, over the magnitude of v. So using this, okay, we can have some examples. Now, The question says determine the direction of the vector with respect to x, y, z. Here we have the first vector, vector A, vector B, vector C, and vector D. So we are supposed to determine the direction with respect to the direction of each vector with respect to the x, the y, and the z axis. Suppose this is vector A. Suppose this is vector A, so that it's okay. Solution. Now for vector A, part A, okay, this is expressed as 4i plus 3j plus 5k. The direction cosines for this is cosine of theta, the angle with respect to the x-axis, is equal to a along the x divided by magnitude of a, providing that theta is equal to cos inverse of ax over magnitude of a. So it's important to find the magnitude of a. Now the magnitude of vector A is the sum of the square of each magnitude. Okay, each magnitude, that means 4x, 4 square plus 3 square plus 5 square. This is equal to square root of 16 plus 9 plus 25. This is 25, 15. So this is square root of 15. Square root of 15. This is equal to 5 square root 2. This is the magnitude of A. So this implies now the first angle of the vector with respect to x is equal to cos inverse of ax is this one, 4 divided by 5 root 2. To rationalize this, okay, multiply by square root of 2 over 2. This is going to be 4 square root of 2 divided by 5 times 2, so that, okay, so this is 2 square root of 2 over 5. This is the direction of, okay, the direction of, this is equal to cos inverse, okay, the direction of the vector with respect to x. In the same manner, the direction of this vector with respect to the y-axis is cos alpha, which is equivalent to a along y divided by the magnitude of a. Then alpha is equal to cos inverse ay divided by magnitude of a. This is equal to cos inverse, the magnitude of ay is 3, okay, 3 divided by 5 root 2. Still we need to rationalize this, okay, times root 2 over 2, so that this is equal to cos inverse 3 root 2 divided by 10 is the direction. So by using calculator, it's possible to have the direction. And the third angle is gamma. So cos gamma is equal to the magnitude of A along Z divided by the magnitude of A, implying gamma is equal to cos inverse AZ divided by magnitude of A. This is equal to cos inverse. Now the magnitude of A along Z is 5 divided by 5 root 2. Now rationalizing by root 2, this is equal to, this is 2. Now root 2 over 2. So theta, now cos inverse root 2 over 2 is gamma. So from our calculator, this is to mean 45 degree. Okay, this is to mean 45 degree. This is to mean okay, 5 alpha, this is to mean 55 degree, and this is to mean 75.8 degrees. 75.8 degrees. So it's possible to determine using this formula, which is to mean. Now this vector is making 45 degree with the z-axis. The direction of the vector with respect to the z-axis is 45 degrees, and this is making 75.8 degrees with respect to with the y-axis, and this is making 55 degrees with the x-axis. Okay, let's see the second one, B. Vector B is 4 along I, 2 along J, and root 5 along K. So the magnitude of B is equal to the square root of the sum of the squares of the magnitude along each axis. This is 4 square plus 2 square plus root 5 square. This is equal to square root of 16 plus 4 plus 5. This is equal to square root of 25. Then magnitude of B is simply 5 units. Then theta, which is the direction or the angle the vector made with the x-axis, okay, is equal to cos inverse of ax divided by magnitude of a. This is equal to cos inverse of ax is 4 divided by 5. This is cos inverse of 0.8. It's about 53 degree. And alpha is equal to cos inverse of ay divided by magnitude of a. This is equal to cos inverse of ay here is 2, okay, 2 divided by the magnitude of b. A is, sorry, this is b, okay, vector b, okay, 2 over 5. This is about 66.4 degrees. This is 66.4 degrees, and this is 37 degrees. Now here we have gamma, which is equal to cos inverse of b along z divided by b, which is equal to cos inverse of z. Here we have root 5 divided by 5. This is equal to 63.4 degrees. 63.4 degrees. So I hope it's becoming easier just to deal with these questions. So I left this for you as an assignment, and let's see number D together. In part D, we are supposed to have a new vector, which is the difference between 2 y's of the vector A and vector B. How do we find 2 y's of vector A? Here we have vector A. 2 y's of 4i plus 3j plus 5k is 2 y's of vector A, minus vector B is 4i plus 2j plus root 5k. So the product here is, this is 8i, 2 times 4 is 8 along I, plus 2 times 3 is 6 along j, plus 2 times 5 is 10 along k. 10 along k minus 4 along I plus 2 along j plus root 5 along k. For convenience, it's better to take out this from square root, so that square root of 5 is 2.24. This is 2.24. So when we add or subtract vectors, it's important to collect vectors under the same direction. So here we have 8 along I, 4 along I. So that 8 minus 4 along I, okay, plus here we have 6 along J and 2 along J. 6 minus, okay, minus 2 along J, okay, and plus here we have 10 along K, 10, and root 5 means 2.24 minus 2.24 along K. This is two ways of vector A minus vector B, providing 4I plus 4J plus 2 is 8, okay, minus 2 is 8, okay, 10 minus 2.24, 7.76, 7.76 along K. This is the product, the difference. Then the magnitude of, first we have to find the direction, okay? It's important to find the magnitude of this new vector 2A minus B. This is equal to the sum of the squares of the result, the difference, okay? 4 squared plus 4 squared plus 7.76 squared. This is 16 plus 16 is 32 plus 7.76 squared. Okay, 7.76 squared is equal to, this is 60.22 plus 32 under square root plus 32 is equal to this 92.22. This is equal to 92.22. Now square root of 92.22 is equal to 9.6. This is equal to 9.6. 9.6. This is the magnitude of the new vector, okay? The new vector twice of A minus vector B, okay, by vector B. So once we have the magnitude of this, it's easy to find, okay, to find the cosines of, or the angles of directions, okay? Theta, which is the vector 2A minus B make with the x-axis, is equal to cosine inverse of AX divided by, cosine inverse of 2y of A minus B, okay, divided by 2y, the resultant of, or the magnitude of this vector. Now cosine of this, okay, cosine of this along x, 2a minus b along x is 2a minus b along x is this one, okay? So that this is equal to cos inverse 2a minus b along x is this one, okay? This is the difference. This is 4 divided by 9.6. 4 divided by 9.6, 4 divided by 9.6 is equal to 0. Okay, this is equal to cos inverse 0.417. Let's see what will be the result. A shift cos 0.417. This is equal to now theta is equal to 65.350 degrees. This is the angle this vector makes with the x-axis. The x-axis. Now do not forget the magnitude of this is 9.6. Now the other angle is alpha is equal to cos inverse of 2a minus b along y, okay, divided by magnitude of 2a, okay, minus b, minus vector b. Oh. Okay. 2a, 6 minus 2 is 4, okay? Again, this is equal to 4 divided by 9.6, okay? 4 divided by 9.6, because 2 y's of a is 6, 6 minus 2 is 4, so that this is cos inverse, 4 divided by 9.6. 4 divided by 9.6, so alpha is the same as theta, okay? This is equal to 65.35 degrees. Now the third angle gamma is equal to cos inverse of 2y's of a, vector a minus b along z divided by magnitude of 2y's of a minus b, 2y's of a minus b. Now 2y's of a is, this is root 5, was found to be 2.24. 2y's of 5 is 10, okay, 10.00. This was about 7 point, okay, this is 6. 10 minus 2.24 is equal to 7.76. 7.76. So this is equal to 7.76 divided by 9.6 cos inverse. Gamma is equal to cos inverse 7.76 divided by 9.6. Okay, 7.76 divided by 9.6 is equal to, this is equal to cos inverse 0.808. Okay, let's check what angle it's going to be. Shift cos 0.808 is equal to, this is 36 degrees. Gamma is equal to 36 degrees. 36 degrees. Now we find, okay, the angles. So to visualize, okay, the location of this is x, this is y, this is z. Now the vector is making 36 degrees with z. 36 degrees. 36 degrees with z. Okay, 36 is okay. And it's making 65 degrees with x, 65 degrees with x. Okay, 65 is somewhat like this. And 65 degrees again with y. 65 degrees with y. So that the vector is actually, it's hard to draw, but the vector is somehow okay, 36, it's closer to the y, because it's making a little smaller angle, and equally far from the y and x-axis. Okay, this is a possible vector. Okay, now it's making 65 and 36 degrees from here. So the possible way to draw this vector is either this way. Okay, so 65, 36. Okay, so 36. Okay, this becomes far. So the possible way to draw this vector, the resultant vector, is this. Thank you for watching. This is HATube, okay? HATube, which is with you as far as you need help. Thank you very much for watching.